Hey, scholars, welcome back to another wonderful video. Today, we're going to continue this journey with fractions, and I'm here to tell us multiplication and fractions, an estimation story. This is really about just understanding what we know about fractions in general, like what fractions are, what they mean, how we identify the different kinds of fractions that there be, as well as then what does that mean when we kind of think about how that ties into multiplication and really where estimation can come in handy. So let's kind of dive into it for starters. And the first piece we really want to be thinking about is like, what do we know about the fraction itself? And there are many different types of ways we show fractions. There's the unit fraction, right? And that's where you have that numerator of one because it is the one piece, it is the one unit that we're using to put everything together. So in this case, 1/3 or 1/4 or 1/10 or 1/57th. Regardless, that unit fraction is that one piece of it, right? If we were to take something and cut it into, four pieces, well, that is the unit fraction is the one piece. And they're all the same size. So this is actually 1/4. This is actually 1/4. This is actually 1/4 as well. They're all the unit fractions. But then that gets us to the next part, right? The next part there then is the fraction itself. And we use this term when we talk about what happens when we put unit fractions together. So in this case, if I put three of them together, I would end up with 3/4. So that's a fraction itself. And typically when we're talking about fractions, when you use the term just fraction, we're talking about the fractional part that is less than one. So when you put all your units together, but you still end up being less than one, you have this scenario where the numerator is smaller than the denominator because you don't have it all. You don't have a whole number. So then we kind of get into this place where we have fractions. I'm not going to have enough space on one page. I didn't even think about this. Fractions equal to 1. And that is the idea of what happens when you fill up with all of your unit fractions. Oh, well, actually, when I have 3 out of 3, that's equal to 1 because I have all 3 unit fractions. And when I put everything together, it is 1 whole. And so a fraction unit to 1, or a fraction unit to 1, did you hear that? That was silly. A fraction equal to 1 is really when you have this concept that you have everything, 4 out of 4, right? I have all of the pieces that I need, which equals 1. So your numerator and your denominator are the same. And mathematically, that's not only equal to 1 because we draw a cool model and shade things in, but again, remember that every fraction is also a division problem. And 5 out of 5, or 5 divided by 5 equals 1. 3 divided by 3 equals 3. 10 divided by 10 equals, wait, I said that wrong. Let me rephrase that. 5 divided by 5 equals 1. 3 divided by 3 equals 1. 10 divided by 10 equals 1. Wow, must be a Friday. So if you think about that, that's our next piece. So we have these unit fractions. We put them together. Those make fractions. When we put them all together, we get a fraction equal to 1. Then we start to get fractions larger than 1. So then that would be the next step in that. So I'm going to do a fun little map here. We have a unit fraction, and that takes us to the fraction. And then that takes us to a fraction equal to 1. And then we start getting fractions larger than 1. And those fractions actually split into 2 different families. It's like my fun little fraction family tree, but it's like a fraction, I don't know, roadmap. It's not really a tree. Anyway, okay, so now this is what happens, right? We start getting fractions. Again, I don't know. I'll go with 1/4. So we have the unit fraction of 1/4, but then maybe we put 3 of them together and we have 3/4. But then we put all 4 of them together and that's equal to 1. But then we have this scenario where all of a sudden we'll actually have more than 4 out of 4, right? Maybe I have 1, 2, 3, 4, 5, 6. So now maybe I have 6 out of 4. And that is larger than 1. And that's the first form we show this. And what we call this is the top-heavy fraction. Trust me, this is going somewhere, by the way. So here's our top-heavy fraction. And then that top-heavy fraction actually can be equivalent to what we call the mixed number, which isn't entirely a fraction because it is a mixture of a whole number and the fraction. So like in this case, again, we know this equals 1, and over here I have 2 out of 4, right? So these are all those pieces. We start with the unit fraction. The unit fractions come together, they make fractions. At one point, when they all come together and make a whole, they equal 1. But then they even go beyond that and they get larger than 1 when they become top heavy. And then we can convert top heavy fractions to mixed numbers. And then we can also convert mixed numbers back into top heavy. So that is what we need to think about when we think about what do we know about fractions. So we know that we have top heavy and mixed numbers are greater than 1. We have fractions that are all of it, I guess, if you will, are equal to 1. And then we have fractions that are smaller than 1. And those are the unit and the fractions themselves. God, I feel like I have to draw another model of that, and maybe some other day I will. So now, where does that take us on this journey of multiplication, right? Why does this come in handy when thinking about multiplication and fractions? And that scenario really comes in handy with something very similar to like a crazy problem in which you had on your assessment. And if you're watching this video and you're not in our at our school, or maybe haven't seen this, that's okay. I hope this is still a helpful, wonderful video to help you. But this is something that happened on our assessment. We have this problem here, which is giant and crazy and looks insane. And underneath it, we have the exact same number, but this time it is multiplied here. And the question actually says to identify which product will be larger, but not actually doing the calculation itself. You're actually not even multiplying itself. So what does that mean? Well, okay, we're gonna start with the big problem, kind of talk about it, and then we'll walk backwards from here. But really, if we stop and think about that, there's a few things that come in handy here. One, well, this is a mixed number. And one thing I know about mixed numbers is they are larger than 1, right? They're larger than 1. So technically, if I was just to estimate, I would know that if I multiplied something larger than 1, although it's just a little bit larger than 1, times this number here, well, then I'm going to get an answer that is actually larger than the number I'm starting with, right? That's really what it comes down to, is that 6,599,000 times something larger than 1 is going to be larger than 6,599,000. And if I look here, well, this is a top heavy fraction, so that's actually a larger one, right? Top heavy. So when I multiply that, that's something larger than 1, then I know my answer will also be larger than 6,599,000 that I have here. Okay, well, that didn't prove anything. They're both going to be bigger. Yeah, that's what multiplication does. What's your point? Well, again, now I can start to think about, oh, well, what amount is larger, right? So let's take a step out and kind of think about, well, what do we know about multiplication? For example, right? If I was 5, not like 5 years old, but if I was in the number 5 and we multiply 5 by 1, well, we get 5. It's the same thing, right? You start with 5, you end with 5. Doesn't change. But if I was 5 and I multiply by 2, well, I end up with 10. So I've increased in value. And if I was 5 and you multiply me by 3, I'm 15. So that value increases even more. So what we multiply by is that gets larger, so does our product, which makes sense because there's more of it. But if we went back into the fraction world, right? If we said, oh, well, I'm 5 and I'm multiplying myself by 1/3, well, that would actually be 5/3 or 1 2/3. I converted there. and we actually get smaller. What? Yeah, it's smaller, right? Which is true, because if I'm multiplying by something smaller than the number one, well, then my answer is going to be smaller because it's less units that I'm using. Okay, so again, how does this help with this big problem I'm looking at? Well, I can just use some reasoning here, right? I can realize that if I'm multiplying something larger, then my product's going to be bigger. Like again, 5 times 2 is 10, 5 times 3 is 15. Those both got larger, but this is bigger than this because I did it 3 times instead of 2 times. So now I can just say, oh, well, look up here. I have 12 eighths. And so I have a top heavy and I have a mixed number. Well, if I convert them to the same, I can actually look at their value. So I'm going to take this top heavy 1 1/8 and turn it into a mixed number. And that actually gets me 9/8. And now I can say, oh, you know what? This is more. So this is actually going to be the larger product. And I didn't even have to multiply. Right? I just had to think about, what do I know about fractions? Well, 12 out of 8 is more than 9 out of 8. So that means I'm multiplying 6,599,000 by more. So it will be the larger value. Now, like I said, we're going to start with this big problem and walk backwards. Let's take this to the next scale. And this is typically where you see this. Like this was one big problem on the assessment, but let's just take that into general math. And we'll see this a lot, right? These questions, and it's the same thing. Like, how can you identify what the product will be without doing math? So something like this, right? Let's take this one. Let's take this, and let's take this, right? So we have 3 problems here. And the idea is just to determine, will your answer be larger than 5, equal to 5, or less than 5, based on what we know about fractions. Sorry, I like that multiplication symbol so much better. So let's think about that concept. And I'm going to start with B because B makes the most sense to me. Because what B is really saying is that I have 5 times, well, this is a fraction equal to 1. 6 divided by 6 is 1. 6 out of 6 is 1 whole. So in this case, if I multiply with 6 out of 6, well, then my answer is going to be equal to the number I started with, right? I started with a 5, I ended with 5 because I'm only multiplying by 1. So nothing changes. If I have one group of 5, that's still 5. If I move up to the top one thing I'm going to understand about 3/4 is that's a fraction. That is a fraction. So I actually don't have to multiply and think about that because fractions are smaller than 1. Therefore, my answer will be smaller. Because again, if I had one group of 5, that's still 5. But if I had less than one group of 5, well, then I'm going to have less than 5, right? And I know I said we're not going to do the math, but let's prove that mathematically. And again, the goal here is you can actually look at the fractions and just know this. And it helps you estimate when you think about products. But let's just prove the math, but we're going to do it over here in this pretend bracket. So 5 times 3/4, which is 5 groups of 3/4, which is 5 times 3 is 15, right? 5 wholes with 3 pieces each, 15 out of 4. 4, 3 equals 12. 12 minus 15 is 3/4. And again, as always, if to mixed numbers or top heavy fractions is confusing in this moment, please go watch the other videos to remember that, because these are skills we've talked about in class. But as you can see, it is smaller. If I start with 5 and I multiply by a number small, my answer is actually smaller than the number I started with. Okay, so now let's last one here and think about what we have here. Well, this is a mixed number, and a mixed number is larger. So if I'm going to multiply 5 times 1 and 6/8, I'm actually going to get a product that is larger than 5. Right? It is larger than 5 because, again, this would be 1, or I mean, it would be 5, right? And then this part of it would be less than 5, but that part would actually be added to our product, and we would end up with more than 5, which is, again, true because this is larger than 1. It's not 2, but it's still larger than 1, so the answer has to be larger than 5. I know that one's a little confusing, so let's also pretend bracket. We're not doing the math, but remember, this whole skill is to be able to look at that in our head and just say, oh yeah, smaller than 1, so it'll be smaller. Equal to 1, cool, it'll be equal. Larger than 1, cool, it will be larger than the number I'm starting with. But again, here, 5 times 1 and 6/8. We actually haven't even talked applying mixed numbers with whole numbers, but we can also just use estimation here as well. 5 times 1 and 6/8. Well, 1 and 6/8, that's about 2, right? It's pretty close to 2. So I'll just estimate to 2, which gives me an answer that would be around 10. And that is larger than 5. And even if I thought that 6/8 was, I don't know, maybe closer to 1/2, well, then 5 times 1/2, well, we know how to multiply by decimals. We've done that. So that would be 25, 7, so 75, but I need one place value, so that'd be 7 and 5 tenths. So again, 7 and 5 tenths is actually bigger than 5. Okay, that's a lot. It's a lot. It's a lot. It's a lot. Let's just play with it again. So I'm gonna go to the next one, and this point, just I don't know, let's say 3. We'll use 3. 3 times 9/5, 3 times 1/3. 3 times 4/4. Let's do another one. Let's do 6 of them. A, B, C, D, E, and then F. And here, let's say 1 and 5/6 times 3. 2/3 times 3 and 77/100 times 3. Okay. All right. So let's play that game, right? Is my answer going to be equal to 3, smaller than 3, or larger than 3? So will my answer be less than or equal to 3, or will it be, oops, wait, I went the wrong way. Or will it be greater than or equal to 3? Or this. That was maybe just for me. That'll make sense when we get to middle school. So here we go. First things first, pay attention to my fraction. What do I know about this fraction? Oh, it's top heavy. Oh, you don't say? I do say it's top heavy. I have 5 pieces that make a whole, but I have 9 of them. So I actually have more than 1. So this is actually going to be larger than 3 if I was to multiply. Okay, great. This one, oh, that's a unit fraction. That's actually that's like the smallest piece of it. So this is actually going to be smaller than 3 because a unit fraction is less than 1. So multiplying 3 by 1 would be 3. Multiplying 3 by anything smaller than 1 is going to be 3. Okay, that is a fraction equal to 1. Therefore, we will be equal to 3. 77/100. Wow, that looks big, but actually that's still less than 1, right? It's still less than 1 because 1 would be 100 out of 100, and this is 77/100. So I'm going to be less than 1. 2 out of 3, that's still less than 1. So, or no, less than 3. Sorry, man. Sorry, rough day today. Less than 3. This one will also be less than 3. And this is a mixed number. So that's larger than 1. So my answer will be larger than 3. Okay. I hope this starts to make some sense. And again, as always, it's always about practicing this stuff. So don't stress it. Don't freak out. It's all good. It's all about practice. It's all about asking questions. And really at the heart of it all is understanding what we know about the unit fraction, the fraction itself, right? The fraction that's equal to 1, the top heavy, and the mixed number. And really does that mean about what we know about the multiplication of everything and how that helps us make estimations. And this will, of course, to be continued. So don't worry, there's more to go with this, but today that's really all we want to talk about. And once again, even though in my head I was like, this will be a short video, I went for a while, but I hope it was worth it. And again, thanks for sticking around. And as always, right, learn from our mistakes. We keep asking questions so things make. Those are our norms. Math is not about just an answer. It's about an exploration. And as everything, thank you for your time, your effort, and your wonderful attitudes. And we'll see you next time.